All right, here we go. It says a rectangular piece of sheet metal with a perimeter of 75 is rolled into a cylinder with open ends. So it's rolled into a Coke can with the tops cut off. And what we're asked to do is, to start off with, is find the volume of the cylinder as a function of x. And the volume for a cylinder is going to be the area of the base, which is going to be a circle for us. The area of the base, that's why it's a capital B, times the height. So once we've done that, we got to give the domain of the function. So let's come back over here to our rectangle, and notice what x is on the cylinder. That's going to be the height here on our rectangle. And so since it's a rectangle, both sides are going to be equal to the same length, and that's our x because it got rolled up and either end just touched the other once it was circled around. Now, if the perimeter is 75, that means that 75 was equal to, perimeter is equal to 2 times the height, or 2 times the length, plus 2 times the width. And we know what our height is, it's x. But we need to figure out what is the other side going to be. So plus 2w. Here's our w, but we don't want w. We want it all in terms of x. So how can we solve for w? So we'll subtract 2x from each side, and that leaves us with 75 minus 2x equals 2w. And lastly, we'll divide everything by 2 to get that w is really equal to, w is equal to 37.5 or 37.5 minus x. All right, so this is going to be 37.5 minus x, and now it's in terms of x. We don't have to have these two variables anymore. We've figured that out. All right, now clearing this back up because we're going to need this space for some more calculations. It says to find the volume of the cylinder. So to find the volume of a cylinder, we have volume in terms of x is going to be, well, how do you find the area of the base? That's 2 times the radius squared, or sorry, pi times the radius squared. Pi times the radius squared times the height. Now, we can figure out the height. We should be pretty good on. We can see that that's going to be our 37.5 minus x. But how do we find the radius? That part might be a little bit tougher. So over here, we're going to write down, we know the circumference of the circle because we've already seen that. That is x. Circumference equals x. And how do you find the circumference of a circle? The circumference of a circle is 2 times the radius times pi. And again, we know this is equal to x. So the circumference is 2 pi r, 2 times the radius times pi. We want to get r by itself because we're going to square that over here. So divide each side by 2 pi. And that leaves us with the radius is x divided by 2 pi. Now it's in terms of x and something that's going to be useful for us. So we've got that the volume is equal to pi times the radius squared, and the radius is x over 2 pi. It's radius squared. And then that times the height, which is 37.5 minus x. All right, we'll multiply this all out. This turns into pi times, let's switch colors to keep it clear. This is going to become pi times x squared over 4 pi squared times 37.5 minus x. Oops, x. And pi divided by pi, so this squared means really pi times pi, and pi divided by pi gives us 1, and so we have just 1 pi down here in the bottom. And so our volume, what we're going to be hitting into the calculator here in just a moment, is that the volume of x is equal to x squared over 4 pi times 37.5 minus x. All right, and it says so we've now written it written the volume as a function of x. We also have to give the domain of the function, and so thinking through what's the smallest x could be. Well, it could be 0. And actually, I'll write it down here on the next page. Domain will be 0. We could just have just a straight line, and it couldn't really actually be 0, so it's going to be less than. And I suppose you could make an argument that it could be or equal to, and we'll go ahead and make it equal to. We just won't have a volume at that location. And then x, and as wide as I could make x, would be up to 37.5. 37.5. And again, if I actually got to 37.5, I would end up with 0 volume again. So that doesn't make a ton of sense. Probably would be best to leave these just less than and less than. But go nuts. Enjoy the or equal to. All right, so now let's hit the calculator here. And let's graph this. So there's our previous graph. We'll clear that one off. And we're going to have v of x, or y, is going to be equal to x squared divided by 4 pi. Where is pi? Four pi. Sorry about this. There it is. 4 pi. It's a little bit tough on the fake calculator here. And then that times 37.5 minus x. All right, and let's go ahead and graph this, find what we get. And so we've got this function that comes on down and heads back up, and it's kind of a tricky graph to really see anything here on the calculator. But we're looking for where that point will be, and I feel like I hit something in wrong here a little bit. Just a moment, let me pause, make sure everything's going all right. All right, so figured out what was going wrong. Sorry for that. I hadn't typed in the parentheses around here, and so the calculator was reading as x squared divided by 4, and then that times pi, when I want to make sure that I'm dividing by pi as well. So, well, I guess for you it didn't really make a difference. You should probably the video just kept on rolling. Anyways, here we are. So when we graph this here, we get something looking like that. And so just to fit it on my graph, I went out to Zoom Fit and got that graph on there. And so now again, we're still looking for the maximum volume. To find the maximum, minimum, or zeros on your calculator, all that stuff, hit second and trace, which gives you that calculator function up there. So I'm really trying to get to calculate, and I want to know what my maximum is. So maximum, and I'm looking for my cursor. There it is. I'm left of my maximum. Hit enter, and now go right of the maximum, and now to the right of it. Enter. Don't guess. Just hit enter again, and it's going to find my maximum for me. And so it says 24.9999999, and y equals 621.699. So really your answer here is 25. What's going on, and this may be happening on your calculator as well, is that it's hitting in each pixel from what I understand. And so as it's getting closer right now, the pixel that's nearest to it is at 24.999, not actually at 25. And so, but you'd be safe to assume 25 would be your maximum, or the x value that would give you your maximum volume, with the volume actually being the maximum volume being 621.7. So hope that helped. All right.